Okay, this is transformations of parent functions. Parent functions that you already know about, maybe quadratics, the absolute value, or square roots. We have the rules and examples. So this is basically some of the basic forms you will see. This is the formula based, all of them put together. And the first example we have is our quadratic equation, f of x equals x squared. You can put this in the calculator. Remember, f of x is really your y, so y equals x squared. You can put this in the calculator, or you can do a table like I did below here. Basically, I just plugged in -2 and got 4, -1 and got 1, 0, 1, and back to 2 and squared it and came up with this little sketch of a graph. We're going to add k and subtract k. This is called a vertical shift up, vertical shift up by 5 units, and also the minus k is down by 5 units. So basically when we're shifting up by 5, basically what I'm doing is I'm taking f of x, I'm changing my k, and I'm going to add 5. So this is going to be plus 5. So basically what I'm doing is I'm just adding 5 here to my y. Because what we're saying, this is x squared plus 5. So all these points here I'm adding 5 to. So from 0, I'm going up 5. 1, 2, 3, 4, 5. From here, it would be 1, 1. 2 goes to 4, so that would be 2, 4, about here. And that's a vertical shift up by 5 units. Okay? Now, if I want to subtract, I want to do x squared. Student agree. X squared minus 5, or you're saying really f of x minus 5, because that's what your f of x equals. You're just shifting it down. So you're really subtracting 5. So this is -5. Here, subtract 5, you get -4. Subtract 5, you get -1, and so forth. So I always start from 0 and do this one. So from here, I'm going down 5. 1, 2, 3, 4, 5. And then we just shift this whole thing down by 5 units. Okay, so am I doing this? 2, 3, 4, 5. So you just shift it like that. Okay? And that's a vertical shift down by 5 units. Using function notation. All right. Here's another one. This is going to be a horizontal shift to the left and to the right. My h is going to be 5 again. I already drew the quadratic equation. Again, this is just like saying f of x is y, your y there. And we're first going to do f of x plus or minus h. Let's do the minus. Now, let me tell you about the equations here. Look here. This is your standard equation here for any kind of actual shift to the left and right. But this is our square. So I'm going to go ahead and put a square here because we're doing the quadratic one. And you can subtract the k from the y if you want. This is another way to write the equation. And basically, k and h, k represents the distance from y, and h represents the distance from x. So if I write this as x minus 5 squared, that means I'm shifting to the right by 5. So I already have my table, but if you can use a calculator, you can do that. You're going to the right by 5. So I'm going 1, 2, 3, 4, 5. And then I use my table of values and draw a horizontal shift to the right. So this was basically this one right here. So this is y equals x minus 5 squared. To shift to the left, basically what you're doing is you're subtracting a negative 5. Because you're going to the left by 5. This in turn is y equals x plus 5 squared. So this is why this is being shifted to the left by 5. So you go 1, 2, 3, 4, 5, up 1 here, and then we're going up to 4 here. So something, let me try to draw this, something like that. So this is a horizontal shift to the left. And that's what you need to notice. When it's a minus, it's to the right on the horizontal shift. And when it's a plus, because of these two negatives, it's to the left. Again, it's a distance from 0. So you could say here that 5 minus 5 is 0. Okay, and this is, you could say negative 5 plus 5 is 0. That's why we shift it to the left. This is to the left. This is to the right. The next one we have is the absolute value function, and we are going to use the terminology stretch and shrink. It's called vertical stretching and shrinking. When a is bigger than 1, and this is written in the form of f of, we can just use y here, y equals a f of x. So when a is bigger than 1, for example, in this case, that means what we're doing is we're multiplying our y by 2. So in this case, this is my y, or f of x, and I'm multiplying this by 2. So this is 2 times the absolute value of x. So I'm just multiplying this column here. So that would be 4, multiplying by 2. So 4, 2, 0, 2, 4. When I plot these two, this point, negative 2, 4, negative 2, 4 is here, 2, 4 is here, 0 is still at 0, 1 goes, negative 1 goes to 2, and 1 goes to 2. So it is stretching, it's a vertical stretch. And the way you can think about a vertical stretch is if you are holding a rubber band and you have more strength than 1, so your strength is greater than 1, that rubber band is going to get narrower, it's going to get thinner, it's going to stretch. So if this was a 3, it would even be narrower because you'd have more strength. So it'd be something like that if it was a 3. Now, when your a is 1/2, that means a is in between 0 and 1. Let's take that, and we're going to take this column here and make it into a half. And I'm going to put it here. Half of 2 is 1. Half of 1 is a half. 0, a half, back to 1. And I'm going to graph that. So 0 goes to 0. 2 goes to a half. No, basically, we're graphing negative 2 with 1. And 2 with 1. Negative 1 goes with half. And it's flatter. So it gets closer and closer to the x-axis here. That's called a vertical shrink. And again, you can use the analogy of a rubber band. If you don't have very much strength, for example, if you only have half the strength, like we had here, then you can't stretch that rubber band. It kind of lays flat and gets more horizontal. So that's called a vertical shrinking. Next one we have is a horizontal stretching or shrinking. I think for students this is the one that's the most confusing. So basically you already know what a quadratic equation looks like, and we want to do f of 2x. Well, I put the x here, but when I write 2x here, I need to put an x in here so that 2 times that x is negative 2. So what I'm going to write here is negative 1, because 2 times negative 1 is negative 2. Here I'm going to put negative 1/2, because 2 times negative 1/2 is negative 1. So you're really dividing your x by the c portion. This is called the c portion. If you're doing y equals f c of x. So since c is bigger than 1, basically we're dividing our x by whatever our c is. In this case, our c equals 2. And then you just graph these points. So, sorry about that. We're going to go negative 1, and we're going to graph this. Negative 1 goes to 4. Negative 1/2 goes to negative 1. So I have this and this. And then I'm just going to, and we're down to 0, and I'm just going to make this symmetric. And so there it is. Okay? Now, when we're going to do the 1/2, and I put it over here, that means I'm going to multiply my x values by 2. If I multiply negative 2 by 2, I get negative 4. Negative 1 by 2, I get negative 2, 0, and then 2 and 4 back again. Now, because 1/2 of negative 4 is 2, so I'm going to plot these points. Negative 4 goes to negative 2. Oh, it goes to 4, sorry. Negative 4 goes to what? 4. Negative 2 goes to negative 1. And of course 0 goes to 0. This is called a horizontal compression. You will use this in pre-cal when you learn more about trig functions. And this will be very helpful. Then we'll do more of this in pre-cal. The next one we have is a square root parent function. I picked perfect squares. Of course, the domain of a square root function is x is greater than or equal to 0 when you're talking about the real number system. And I did my table here. And what we're going to be talking about now is reflections about the x-axis and the y-axis. This one is about the x-axis because we're changing our y. If this is our y here, basically this is saying negative y. So since we have 3 here, that's going to be negative 3. 2 here, that's going to be negative 2. So this is your negative y. 1 here, that is negative 1, and then 0. So I'm going to plot those values. And you're going to notice 9. So 9 is where? 1, 2, 3, 4, 5, 6, 7, 8, 9. Goes down to negative 3. 4, 1, 2, 3, 4 goes to negative 2. 1 goes to negative 1. You're back to 0. And if you plot this, you can see where it reflects over the x-axis. That means if you fold this on the x-axis here, these two lines should match up. Now for this one, this is going to be reflection over the y. And what this states is that we're going to make our x negative. So basically, I'm going to put the negative here, negative x. And I'm going to make my x negative. So this is negative 9, negative 4, -1, and 0. And when you plot that, so I'm going to plot the 0, 0, -1. And what we're plotting basically is this point. We're plotting -9 with 3, -4 with 2, -1 with 1, and 0, 0. So -1 goes to 1, -4 goes to 2, and -9, way down here, 4, 5, 6, 7, 8, 9, goes to 3. So I think that's about right. So you can see where this reflects over the y-axis. If you fold it on the y-axis, this would reflect over. And that is all. Study this, practice this, and I hope you do well.